Welcome back to the Structured Cabling lecture series. This is lesson number 3. So if you haven't seen the previous lectures, I will post a link in the description for the playlist. In this lesson, we will cover copper cabling basics. Remember from the previous lecture, the difference between de facto standard and de jure standard. De facto standards are standard typically temporarily adapted by multiple organizations in the industry, and when it become widely accepted, it become a de facto standard that is not recognized by a formal body or legal authority. So in other words, there are no standard at the beginning, so the structured cabling companies and IT companies decided to adapt a particular way of doing things, and those become de facto standards. De jure standards are permanent implementations of standards. Those may be initially de facto standards that become popular without centralized body, but eventually the ratification happen, and as a result we will end up with a de jure standard. Later, these standards may be ratified therefore by laws, codes and regulations as well. So you could have an independent body such as TIA or someone standardizing it, and then later may be ratified by actual legal codes and regulations such as Canadian Electrical Code, for example. We also cover pinouts such as the T568A and T568B in my previous lecture. So if you haven't seen that, you can go and check that as well. And we also cover modern copper cabling standards that are defined based on CAT or category system. I mentioned that in my previous lecture, and we will cover a little bit of that in here in this lecture as well. So this is just a recall of what I have already covered in our previous lecture. So today we're going to look at what is a twisted pair cable and different cabling standard and how those cables are made. And that information is important as an IT professional, because once you understand the cabling standards and how those twisted pair cables are created, then you can make the correct decision for your customer. So you may have heard the term twisted pair a lot in the industry and also in a consumer level as well. And the term twisted pair is used to describe the cable itself as opposed to the strand. So for example, if somebody said twisted pair, that actually means the twisted pair cable, not the twisted pair wire, because actual a twisted single pair is not actually called twisted pair. It is instead of called a balance cable. So if you have two wires that actually intertwine, that's actually called a balance cable. So when the term twisted pair is used in the industry, it's typically referring to the cable itself. So you will have not one single twisted pair, you're going to have multiple twisted pairs. For example, Cat5e, Cat6 cables, they always have multiple twisted pair because that's what we need to transmit packets in a packet switch network. So the twisted pair cables consist of several pairs of copper conductors, not single pair, but several pairs of copper conductors. And two wires twisted is called a balance cable or balance line. And this was first used as a standard in the telecommunication industry, especially by AT&T and Bell Laboratories in the early stages of the implementing telecom standards. So the balance cable, keep that in mind, is just two wires twisted together. But a twisted pair is two wires twisted together along with a bunch of other two wires that are twisted together, create a twisted pair cable. Why twist the cables or these wires? Actually not the cables, the wires themselves at the first place? Well, the reason for that is the two conductors of a single circuit are twisted together for the purpose of improving electromagnetic issues. So by twisting two conductors, in other words two wires together, even though they are isolated against each other, we basically eliminate certain interferences, basically signal attenuation issues, electromagnetic interference, etc., etc. So that's why we twist the wires at the first place. And keep in mind, those twisted pair cables are color coded, and I will go into how the bundle of cabling color coding works in my future lectures. So in this lecture, we are not going to cover the exact color coding, but I will cover the the cable color coding in future lectures. What you need to understand is what is a twisted pair cable here, and the twisted pair cable is basically describe the cable itself, and it contains multiple twisted pairs that combine together create a twisted pair cable for Ethernet use, such as Cat5e and Cat6 cable. So that is what we call a twisted pair cable. So if you look at the twisted pair basic elements, you will notice that you have an outer sheath. The outer sheath is like basically a protective cover. I'll go into a little bit more detail in the next few slides, but then we will have the thin copper braiding in some cables, or you may have a aluminum foil shield, and you may have an individual shielded pair if it is that type of cable. Or you may have no shielding at all, and then you will have other components associated with that, such as the separators, the drain wires or pull wires, etc, etc. And then each of these wires, as I mentioned before, that is being twisted will have its own isolation covers. Like in here we'll have isolation cover, and then on top of that you'll have an individual shield in here. But in here we have the isolation cover, but there is no individual shield between the twisted copper wires. So those are all different grades or different types of cables, which I will cover in the next few slides as well. But just remember that these are some basic elements or basic components of these twisted pair wires. Copper conductors. So I'm going to go over a few concepts associated with copper conductors. There are actually two concepts. One of them called the solid conductor, the other one called the standard conductor. You may have heard these two terms in the industry or when you go and buy consumer grade cables as well. And there is a reason why we have these two different types. So the solid conductors are typically used for cables that are used for backbone cabling, and not suitable for regular flexors and bends because it costs well, because it's a solid copper cable inside there. If you keep bending the cable back and forth, it might degenerate the cable, it might create connectivity issues or even completely break off. And the transmission performance over long distance of these type of cables are really good compared to standard conductors. And when it comes to the point, the standard conductors, on the other hand, in contrast, they are made out of several small wires woven together to create a single wire. So if you take a single wire, the standard conductor will have a bunch of tiny little wires that actually stranded together. And they are very suitable for regular flexes and bends and impacts. So in other words, if you have a standard conductor type cable, and if you take this Cat5 cable and you'd actually bend it and back and forth, it takes a lot of that back and forth bend even to get that thing wear out and cause problems. As opposed to solid conductors, as I mentioned, if you flex and bend too much, it'll wear off really fast. So standard conductors are very suitable for regular flex, bends and impacts, and higher signal attenuation, however, is a problem with these type of standard conductors because of the type of that conductor. Over long distance or long runs, signal attenuation become a problem in this type of standard conductors. These are typically used in end connections, intermediary devices, etc. In other words, majority of patch cables that you will find in the market or the patch cable that you will be making in the industry will be using these standard conductors. So the solid conductors are mostly for backbone using, and the standard conductors are for patch panel cabling. And another thing you need to understand is that when it's come to the point, flexing and bending is something called the bend radius, which become very important, especially in the fiber optics or optical fiber cabling, but also become an issue in here as well. Bend radius is basically if you have a cable and it will get you an idea or a quantitative measurement of how much the cable can be bent before it start to degrade. So it doesn't necessarily have to be completely damaged, but it can degrade the signal. For example, if you have like if you have a tube like this or something like that, and if you have a cable and that cable, like how far that cable can wrap around that, like how tight that cable can wound around this. So if you have a cable coming in like that, and how tight that radius that the cable can bend over it, and that amount, this distance is what we call the bend radius. I will go into more depth about bend radius on my lecture on fiber optics or optical fiber cable. But just for now, just remember that the solid conductors have a lower bend radius compared to standard conductors, because you can bend it far more greater way, like more acutely, and then as a result that the standard conductors are more, I would say, more resistant to breakage and wear compared to solid conductors. However, the reason why we use solid conductors, because the transmission performance is lower or over long distance is better. And another thing I should mention is that the standard conductors typically cheaper to produce compared to solid conductor type cables in Ethernet. So keep that in mind. That's another reason why people use standard conductors whenever it is necessary or easier to use. The cost associated with that standard conductors are also lower than the solid conductors. So in here, my picture on all of my lectures at the very beginning, this is a stock image that I downloaded from the internet. All of these cables that are copper wire cables, these ones are actually standard cables, because the way that it is bending, needed to be bended here, most likely those are those cables. And you can see some fiber optics cables right here, and these fiber cables, for example, this one is a fiber cable right here, and these fiber cables are not suitable for having a very low radius. So if you this fiber cable, if you turn it really tightly in here, if you wound it really tightly here, it will break, or it'll start, the signals start to degenerate. So keep that in mind when you are working with this fiber cable. But all of these other patch panel cables here, this is a patch panel right here, and these cables are standard cables as opposed to solid wire cable. But whatever behind here at the building in here, they probably use the solid copper wire cables. So here's a cross section of a UTP cable, two UTP cables, both of them are U/UTPs. What this means, I will describe in the next few slides. So the solid cables will have the jacket, the outer sheath. I sometimes call it the jacket, and then you have the ripcord, or the grounding cord as well. Sometimes it could be a grounding cord, and then we will have the copper conductors, and they are solid inside. So those are the solid ones. And then the UTP, the standard one, will have the stranded cables that are stranded together, wound inside here on each of these wire, and those wounded strands create that one single wire. So both of them could have 20, like the same gauge, for example, but one could be stranded and the one could be solid. This is important as an IT professional to understand, because depending on whether you have the stranded or the solid, your endpoint connectors are different. I've seen many people use the wrong connectors, like the RJ45 connectors, and they crimp the wrong connector at the end. So that is a bad idea. You should not be using connectors made for stranded on solid or solid on stranded. Again, I will explain this in my future lecture videos. I'm just trying to cover the background basics in this video, but keep in mind whether you have a stranded copper wire or a solid copper wire matters when you are working with structured cabling, because of the end connectors and everything may have to be changed. Insulation and separation. So the purpose of insulation here is basically, one is to prevent corrosion. So try to shield from the environmental elements, and also to isolate between conductors. Like for example, if you go back to the previous slide, the reason why we have this type of insulation between these wires is basically to isolate these wires from each other, but the outer stealth is mostly to protect from environmental elements. So the insulation do two things as a result. The most common type of insulation is the high density polystyrene, also known as HDPE. They are widely used in many other applications as well. They are very flexible. They're used in, for example, vehicles and home furniture, etc. as well. And they are used in our structured cabling infrastructure as well. Cat 6A and above typically use something called foam polystyrene or FPE that gives better insulation coverage. In other words, you provide better electromagnetic interference coverages, etc., etc. High temperature insulations also use in there are situations where installations has to be done in a high temperature environment. In that situation, we use Teflon. The reason why we don't use Teflon everywhere is the cost, because use of FPE and HDPE is cheaper compared to Teflon. The separators between pairs that are used in Cat 6 and Cat 6A cables are typically plastic. Those separators I showed you in a couple of slides ago. So if you go back, this separator right here, this is typically plastic right here. And those separators actually again increase the shielding for interference. So in other words, it's actually decrease electromagnetic interference. That's what these separations, separators of those pairs going to do. So it will decrease the signal attenuation and increase the shielding for electrical interference. That's what those separators of going to do. Drain and ripcord. So drain wires and ripcords are two different things, but sometimes can be the same. So you could have a ripcord that is also acting as a drain wire. Drain wire is used as an earthing element which remain in contact with the metallic side of the shielding tape. In other words, if you have a cable with a metallic shield like this, it might have a drain wire that can be grounded because now there's more metal exposed in this cable outside of the twisted pairs. So outside this, so you will have a drain wire like this that will be in contact with aluminum or other metal shielding, and this drain wire probably going to be metal. Why? Because then now you have the ability to ground this cable, especially in outside insulation. Ripcord is used to cut back the jacket to expose the wires of the cable. This should say used to cut back, not cross back. Sorry about that. So sometimes the drain wire is also acting as a ripcord, allowing you to pull from this wire, and then it can rip through the outer shield, and that will allow you to expose the cable for insulation purposes. So some cable use wire to achieve both these tasks. So use like a single wire to achieve both of these tasks, but some cables may have two cables associated with this too. So if you don't have an aluminum shield or a metal shield here, this particular ripcord most likely going to be some kind of a nylon ripcord. But if you have aluminum shielding, this ripcord could be a drain wire and a ripcord in one. In that case, you will have this wire in a metal way. How you rip it? Basically, you wrap one of these wires around your finger or like a metal device. We don't recommend using a finger actually. In the industry, you use like a tool, you could use pliers or something, and you can wrap this end on your pliers and then pull it. And pulling it will break this thing apart and let you install the wires accordingly. So it basically break this shield and everything apart, so you can get these twisted paired pulled apart from this wire. Next thing, we're going to look at the outer stealth, or sometimes called the jacket, which is the one that I keep referring to as this one, this PVC jacket in this example right here. So it's sometimes called outer sheath, sheath, outer sheath, sometimes called outer jacket. And so the outer sheath protects internal elements of cable from environmental effects such as low temperatures, moisture, UV rays, and physical impacts. So there are some UV rated cables that you can put it outside a house or outside a building that would have that specifically designed outer sheath or jacket that will prevent the wire from degrading due to UV rays. The most commonly used outer sheath or jacket are LS-ZH, known as the low smoke zero halogen. The other one is a PVC, it's a polyvinyl chloride one. LS-ZH is recommended for indoor use. In fact, in the Canadian Electrical Code as well as safety standard, it is highly recommended, the fire standards as well, that you use LS-ZH. It may be actually the code in Canada right now. I haven't checked that yet. This is because LS-ZH is, when it burns, it doesn't produce fumes that may be harmful to humans and animals. So that's why LS-ZH is highly recommended for internal use. PE, which is the it's a type of polystyrene, and which is the outer sheath that is used for outdoor cabling. It provides UV protection. However, it is also highly combustible. So it's good for UV protection, not for combustibility. This is good, not so good for UV protection, but it's really great for in terms of like burning inside a building in a case of an emergency. It won't create any fumes. So you need to pick the wires based on where you're going to install your structured cabling as an IT professional. So keep that in mind. The reason why we have different sheath or jackets, because they perform different functions depending on where you are installing and how you're going to use those cables. Other key elements includes the polyester film, which is used for additional protection for pairs, insulation, as well as it separate pairs and shielding foil. Overall, aluminum foil shield is another one which reduces the external induced noise, which if a cable, aluminum foil is the basic type of shielding that you find in cabling today. Individual shielding of each pair is also used for protection from external noise, electromagnetic noise, or internal electromagnetic interference as well. So it reduces the crosstalk between the pairs in terms of internal interference within one cable. So this is where you find this type of this type of shielding you will find in Cat 6A and Cat 6 and up cables typically. So that's where it comes into play, because it improves the transmission quality of that wire. Thin copper braiding provides better additional protection from interference as well as strong physical effect, and in addition it serves as a drain wire as well. So categories of cable, I have been talking about categories of cable here and there, but if you want to look at the EIA, ITA, ISO, IEC established categories, those categories goes from category 1 all the way to category 8 plus, etc., right? For most commonly used categories right now, either been in the market for a long time or currently in use in the market, include category number 1 all the way to category number 6, exception for maybe a few categories in between that are no longer in use. Category 1 cable are the first type of cable to be standardized, hence category 1, and it has a minimum standard that needs to support, which is the 1 megabyte per second, and it is typically used in telecommunication industry in the early days of the industry. And then Cat 2 came along, which allow 4 megabyte per second minimum standard, and it allow local talk and telephone relays. And then the Cat 3 came about, which is 10BASE-T Ethernet cables. So in the really old buildings, you may still find these Cat 3 cables used for Ethernet, but nowadays at 2022, nobody uses Cat 3 cables for any of the newer installation of Ethernet. Then Cat 4 came along, which is a token ring, which is used, I believe, by IBM. That didn't last very long. It is proprietary most of the time, and the most cabling manufacturers didn't use Cat 4, so it didn't catch on at all. So you may find Cat 3, for example, in the wild. Cat 4, I hardly believe that you will ever even come across a Cat 4 cable in the industry. Cat 5 and Cat 5e are the most common type of cables that you as a IT professional or a home user of the internet may be familiar with. Most homes are wired in either Cat5 or Cat5e cables, and the Cat5 has two types, one called the 2-pair and the other one called 4-pair. And the one that you may be familiar with at home is the Cat5 4-pair cable, which allow gigabit Ethernet connection, or Cat5e cable, which also allow gigabit Ethernet connection but have better shielding and better transmission quality. So those are the two cables, Cat5 and Cat5e, in the Cat5 4-pair and Cat5e, that you may be mostly familiar with for network Ethernet cabling in either buildings or in homes. Cat6 is a newer standard that allow 10,000 megabyte per second, which is again a gigabit Ethernet standard, and it can allow, support up to that 10,000 megabyte per second standard. Keep in mind, standards from our previous lectures, recall, basically dictate the minimum speed and minimum specification that a cable needs to support. It doesn't have a maximum. So like a Cat6 cable that you have at home may have really good quality cabling materials and may support a little bit above 10,000 megabyte per second. But what make it a Cat6 is that it supports at least 10,000 megabyte per second. So keep that in mind. Recall from my previous lectures that I have mentioned before. So again, now we are moving on to Cat6a, Cat7, Cat7a, Cat 8.1, Cat 8.2, etc., etc. As time goes on, those standards will come into the market. So right now, as of 2022, as an IT industry professional, what you need to be familiar with is the Cat5e, Cat6, maybe Cat6a, as you are installing those cables. When it's come to the point designations of cables, it comes in a number like this. So you have a value in here. We'll have like a U, F, S, or SF described here, and after the slash, let's say it's S slash, then you will have the whether it's going to be shielding type. It's going to be UF, for example. U mean unshielded, F mean foil, and then you have the TP, that how many twisted pairs, like how it is. TP stand for twisted pair, so it's going to be have TP written there. So you can have either U, F, SF here. You will have either U or F here, and then you have TP here. So that's the ISO ICE 11801 standard, and this is how we actually designate the cable, and that's how you identify. So again, I'm not going to go into detail on these categorizations today, but I'm going to give you a big overview so you have at least the introductory background to how we identify cables. So on the next slide, for example, we have a UTP cable that basically gives you this last part, UTP. U stand for unshielded, and it's a twisted pair, therefore UTP. Shielded will have STP. Remember, UTP is cheaper compared to STP, so that's why we have them. So unshielded twisted pair, or UTP, is the most popular type. It is cost effective. As I mentioned, it's very cheap compared to the cost gonna increase with the STPs, especially for longer run. The UTP is cheaper, but it does come at a cost benefit issue, which you will realize eventually as you go through this course. And these are typically for telephone grade all the way up to the high-speed data transmission grade. So you can use UTP cable for telephone communication all the way to Ethernet network communications. There are 4 pair of wires twisted with different number of twists. Now, the reason why each pair has a different number of twists is to eliminate interference. And also you need to understand, the tighter the twisting, the higher the supported transmission rate. So in other words, tighter twisted wires cost more, but it also means that it will support higher transmission rate. What that means is basically you have these two wires, and tighter you wind them against each other, so tighter you twist these two together, the higher transmission rate that it will support, but the cost will going to go up. And the reason why we are twisting these wires at a different rate, for example, if this one is twisted in a certain rate, this one is twisted in a different rate, this one is twisted in a different rate, and this one is twisted in a different rate. Not all of these sets are twisted at the same rate. The reason why we do that will eliminate interference, because if this is twisted at the same rate, so every couple of centimeters there are a couple of twists, to twist, and this is the same, that might actually create an electromagnetic interference. As a result, we always try to twist all of these pairs at a different rate in a single cable. So tighter the twist, better the transmission quality, but even the tighter twist wires, each pair will be twisted at a different rate of twist to eliminate the electromagnetic interference. And at the end of these wires in Ethernet connectors, we use the RJ45 connector, which I have introduced in my previous lecture. And the designations on these wires, for example, are going to be U/UTP. So it will say U, that means unshielded, and then /UTP stand for unshielded twisted pair, for example. So that's how the designations work. This is an example of a designation. So I mentioned shielded and unshielded, and I described them a little bit here and there on my previous slides. And here's an overview of what cable shielding actually means. So the shielding is used to reduce electromagnetic interference, as I repeated multiple times. Established standard includes the UFTP, FUTP, SUTP, SFUTP, etc., as well as FTP, etc. So what they actually describing here, which is according to the standard that I have mentioned here, it's based on this particular method of describing, is the individual shield, overall shield, and individual and overall shield. As an IT professional, you should know what these are, but today I'm not going to go into depth of what they are in this particular lecture. I'm just introducing you to these concepts because I don't want to keep this lecture very long. This is already over 30 minutes long, so I don't want to go any longer. So before these standards, early examples of shielded twisted pair was the IBM STP-A, which is a 2-pair 150 ohms SFTP cable defined in the 1985 by the IBM cabling system specifications and used with token ring or FDDI networks. You just need to know the history part of this. You don't need to know much about this unless your instructor in particular course you are taking asks you to remember these things. So as IT professional, you should know where the standard first started, but you don't need to know a specific days. Know that it was done in around 1985 by the IBM. And then later we end up having all of these standards describe here, the individual shield, overall shield, individual and overall shield, as we progress through time. And on the right hand side, I have this diagram. These are 3 types of 10 gigabit base T cable. One is FUTP, the other one is UFTP, the other one is FFTP. And you can see the foil, where the foil goes in and how much of foil is used changes as you move from left to right. And when we have F/FTP type of cable, we have foils put more foil usage. As a result, it have high noise resistant up here and support higher transmission and better quality packet switching compared to FUTP. So that's why why we have different standards. Again, keep in mind you need to do cost benefit analysis when you are installing cables at any site, because the cost of this cable is much higher compared to the cost of this cable. So in terms of cable shielding, here are some abbreviations that you will come across in the industry, and you can pause this video and just read this table. This table is actually from Wikipedia. It's a standard table. Just know these standards exist and know what they mean in a general sense, so that as you work in the IT industry on the front line as an IT technician, you have a better understanding of what type of cabling you are using. And again, you don't need to memorize this, but you should know these standards exist. Again, this is another example of 3 images of SUTP, STP, and SSTP cables. Again, it shows the type of shielding that we have. So pairs are shielded here, and in here none of the pairs are shielded, for example. So it's a SUTP, unshielded twisted pair. And in here STP, you have everything, every pair shielded. And this one, in addition to the every pair that has been shielded, we also have an additional shield outside. The cable itself is shielded before the sheath come into play. So as you can see, the cost of this material, these cables goes up as you move from left to right. So that's what keep in mind. And that's everything for today. And I hope you learned something in this lecture. If you like these type of lectures, please make sure to thumbs up and subscribe to my channel. Until next lecture, good luck with your exams and have a nice day.